So I have to know, so we're on the second day. What has been some of your favorite talks or favorite topics? Now you guys all go quiet, so. Okay, cool. Did anyone see Richard Campbell's nuclear discussion yesterday? That was good. I came in about halfway through. Richard's a interesting fellow. If you tell him, hey, I just read this book, he'll go, oh, I read that like 2 years ago. I have not read a book that he has not read. So it's amazing. He is a prolific thinker and writer and reader. So, well, cool. It is nice to be in air conditioning a little bit. So I thought it was going to be cool in Denmark, but it is actually cooler. I'm from Michigan in the States, and it was getting up to, my wife told me yesterday and the day before, it was trying to calculate Celsius, 38 or 39 degrees. And my daughter just went to college last week. She's our youngest, and we moved her into the dormitories where she's going to live, and her dorm has no air, and she's up on the 4th floor, and she just like, Dad, it's so hot. It's so hot. So I know it. Well, I lived through that too. So I lived up on the 5th floor of my dorm. So you just have to live with it for a few days. So, but yeah. And then someone told me last year it was freezing at this event last year. Did anyone go last year? Come to this last year? Was it cold? And rain. Yeah. Okay. Well. Welcome, everyone. I was amazed when I walked in. I thought this might be a little like classroom, but wow. So, sorry if I'm sweating a little bit. It's just the heat. Like I said, I live in Michigan, so it doesn't get super hot there. A hot day in Michigan is around 90 degrees Fahrenheit, which is what, about 34, 33, somewhere around there. So, but I'm just trying to kill time. And so, anyone else have a good talk that they went to yesterday or today, or the what? Rockstar. That was an awesome keynote. Yes. And they're going to be playing that song tonight. The whole band will play that Fizz Buzz song. So I was actually outside trying to get into the cooler weather with the little breeze, and I was listening to the band rehearse. So I think they're going to do a good job. So, okay. I see a few people from my workshop yesterday that I didn't scare off too bad. Okay. How many are .NET developers, C# developers in here? Okay, that's the only prerequisite that you have to really have for this talk, is you have to know C# and work in it a little bit. So. And please ask questions. Please just speak up or put your hand up, and if I make a mistake or you don't agree with something, please let me know. I have a very thick skin. I can be told that I'm wrong. So we'll start because this is live streamed and recorded. So will you give me the thumbs up when you're ready? Okay, well, people are still coming in, so we have another minute. Someone said that in the last time I did this talk that they thought this looked like a tombstone. And I was saying like C# was dead, and which isn't the case. It's not the case. So. Okay, we got another 30 seconds for people to come in before I start. I like to be right on time. So we got another 10 seconds. So, okay, I guess we can start. Okay, so we're going to talk about Rust. And we're going to talk about kind of comparing and contrasting Rust to C#. So I've been trying to learn Rust for about the last like 4 or 5 months. I've been trying to put in 3-4 hours a week to just learn it and work with it. And I wanted to kind of share how I see Rust for a C# developer. And if you have any interest to move over to that, what you're going to kind of get moving over and becoming a Rustitarian, or I think they call them Rustitarian. So this talk is going to be all slides. There are code on the slides, but I'm not going to do any demos. I find that if I try to type in front of people, it never works out well. I'm not a typer and a talker at the same time. So, okay, so if we take a look at C#, so I'm gonna share a lot of things that you probably already know about C#, but bear with me, okay? So C# is really good at web development. We all probably use ASP.NET and ASP.NET Core and Web API and minimal APIs, so it's really good for that. It's also good for cloud development. I mean, Microsoft basically has Azure for pretty much everything .NET. Windows apps, we all used to do. How many people are still developing Windows apps, non-Windows or non-web apps? Okay, a good number. How many people are doing MAUI? One person, okay, yeah. I was listening to Dylan and Mark Rendell talk about that, and they asked who was doing MAUI, and so I just had to say, and they got one person that was doing MAUI in their talk. So, but game development, it's really popular. You don't really think of C# as a gaming language, but with Unity it is. Anyone use Unity here? Okay, a few. Web APIs. Now Rust. So before I put this list up, what do you think Rust is good at? What? Speed. And what type of programming or what type of data? Yep. What else needs speed? Well, operating systems need speed, right? We need to have an efficient way. You know what's interesting? Who uses Windows in here? Microsoft develops Windows. Now they are migrating over most of their C# or C++ code to Rust because it brings a lot of benefits. WebAssembly and WASM apps, embedded systems. So Rust is really good for embedded systems and small devices, network systems. Cryptography, so it has a really good cryptography library that you can use. And you can still do web development and web APIs, and we'll talk about that towards the end of the talk. So let's talk about just the language. So let's compare C# to Rust, and let's see how they compare and which one does things and which ones doesn't do things. So comparison for Rust to C#. So we all know that C# is really heavy in OOP. We have classes and we have interfaces, And we can do inheritance. We can do inheritance many different ways. Rust is OOP, it's object-oriented, but it doesn't do inheritance. It uses what we call, we have structs. So what you think is a class in Rust is really a structure, and a structure just has properties, and then you can apply behaviors to it, and we'll take a look at that. But there are no inheritance in Rust. And then C# relies on the garbage manager or garbage collector. And anyone understand garbage collector? I mean, truly understands it, like understands like when something actually gets disposed of, or how, like, all the steps. There's not too many people, and I know people at Microsoft that work on the garbage collector, and it's very complex. Well, Rust doesn't have a garbage collector. It uses an ownership model to keep memory for variables and for other things around as long as they're owned by something. And we'll talk about that, ownership and borrowing and sharing. Both languages can do functional programming concepts. Rust is really good at pattern matching. So if you need kind of that really fast pattern matching, it's really good. And this is the most important thing with Rust, immutability. When you create something, by default, every object is immutable. And that's interesting with Rust because it's the opposite with C#. So if you want to make something mutable in Rust, you have to tell the compiler that this needs to be mutable. And then its concurrency model is really interesting. So we'll take a look at that in a little while, but Rust has a really wonderful compiler, and the way that the language was created, it allows the compiler to say, I will not compile this because there could be a race condition here, or there could be a thread issue here. So you get a lot of feedback when you compile your code. So it will not let you have issues or potential issues with multi-threading and sharing resources between threads. And we'll take a look at that also. And this is probably the second interesting thing with Rust. They both Rust and C# do async programming. Rust is a little more native, where C#, it was kind of added into the language during the lifetime. I think it came in around C# 6 that we got async and await. So let's take a look at some code. So I'm going to look down on the TV screen here. So in C#, we can see how we can create an int and a string and a Boolean, and those are what we've all seen every day. So the Rust side is this concept of let. So you always have to say let, variable name, and then you have to give it a type, and then you have to equal something. So the other thing with Rust that's interesting is Rust variables cannot be null. There has to be something assigned to a variable. So Rust is you can't unassign something and have that variable still around. So nullability is not allowed in Rust. So in this case, over here we can just say int, and the compiler will usually create either an int32 or an int64. It kind of, most of us don't really care what the size of the int is for C#, but we have to declare what type this is. Or we'll take a look at another way to do it that we'll talk about in a few minutes, but we have to say like I32. So this is a integer of 32-bit. And then we have a string, and yes, that is how we declare a string. It's an @ and then str, and then a bool is just a bool. And all of these variables are mutable. All of these variables are immutable. So let's take a look at functions. So we can see C# has an add that adds two numbers, two ints together, and it returns the two products or two ints added together. And we can see a string where we send in a string and we return back something else from another string from the function. Well, we can do the same thing in Rust. We just say fn, and then we say add, and then we come in and say, well, we'll take two int32s, and then that will return another I32, and then we add the two variables together, the two values together. Anyone see something strange with that first function? There's no return. Rust compiler, Rust will infer, it infers quite a bit. So we have a lot of inferring in C#. Rust takes it to the next level. So Rust will infer what needs to be returned. So you don't have to say return this. It will just say it's at the end of the scope of the function, and it looks like it meets what I need to return back, so I'm just gonna return that back. Just like in the second one, where we just format a string, it just knows, hey, I formatted a string, there's nothing else in this function, I'm gonna return that as the string that needs to be returned back to the caller of this function. So slight difference in thinking between kind of the way that functions work. There's not much difference, but it's just different enough to make you remember about these differences. So let's take a look at conditionals. This is where pretty much they're pretty equal. We have over here we have a check to see if number, which is an int, is greater than 5. Over here we check to see if a number is greater than 5. We don't have to use parentheses with Rust, but pretty much everything else is the same. So the only thing that I don't even think you can put parentheses in there. It will bark out a compilation error. So loops. So we're looking at a traditional for loop in C#, where we declare an int and we do the conditional, and then we increment it, or we can decrease the value, but we're doing something, we're doing a while loop. So for Rust, if we wanted to do that same for loop, we would just say for I in 0 point or period 5. So it infers what I is. So you don't have to say I is an int. It's just going to say, you know what, you're dealing with 0 and 5, I'll make an int 32. Usually, most things are int 32s or int 64s, depending on the operating system. And then the while is very much like the other one, except we don't have the parentheses. Basic error handling. This is where the two sides differ quite differently. So we can see try, catch. C#, we all rely on try, catch, except. And Rust doesn't have that. Rust doesn't have a way to catch errors. So we explicitly have to build that in. So in this case, if you're looking, we are having to do that check to see if b is equal to 0, so we can then say cannot divide by 0. So is there anything else that's different on the Rust side that you see? What's that? Yeah, the return type. So you can see that ER, the error, or an OK. So what Rust doesn't, when we create a function, Rust has this special way of having a return type that actually has two properties to it. So the first property is the result of it, either an error or an OK. And then the second is the value or what is being sent back. In this case, it's either getting sent back an ERR and a string that goes along with it, or it's going to send back an OK with the actual result for that function. So in this case, if you do try to send in B and try to divide by 0, it's going to send back an error. You can not catch, but you can factor in on the call, you can say, if this is an error, do this, and if it's okay. So Rust can kind of figure out when it gets the return what to do after that. Any questions at this point? No? Yeah. Yeah, if you don't check, it won't compile. The Rust compiler will say, you know what, you've done something that I can't allow this program to compile. So you'll get a compilation error because it knows that you can't divide by 0. Okay, so the difference between some stuff between C# and Rust that we'll take a look at. Rust has classes, and we've already talked about, C# has classes, C# has interfaces and inheritance. We all know that. Rust has structs, traits, and no inheritance. So we'll take a look at some code to show how we do both, how we do the C# and how we do Rust. First, we're going to take a look at Rust. Oh, I'm sorry. First, we're going to take a look at C#. I put Rust in here on accident. But this is C# code. You can see we have an interface of iShape that has a definition, a contract that it has to have anything that uses that interface has to have an area function that returns a double. And you can see that we are creating a class called circle that adheres to the iShape interface, and there is a double function that's called area. So very simple. And this is not Rust, but this is actually, this is not C#, this is Rust. So we can see that we have a trait called shape. And shape has a definition that if a struct uses a trait, it has to implement, in this case, a function called area that takes in itself. That at self is basically it's saying take in my own value, and it's going to return an F64, a float, 64-bit float. And then we can see that we have a struct called circle, and that has a radius. And then we have a two ways that we can implement circle. We can explicitly implement circle and send back this function to do something, or we can say implement shape for circle, which is kind of like an interface. So by doing this, I have to, that struct called circle, which is kind of like a C# class, has to have a function, it has to have an implementation of a function called area, and in this case, it calculates, and you can see it calculates everything. So you can see up here, we have this std : f64 : const : pi. So that is just a full declaration on how to get pi from the standard library that comes along with Rust. So you can kind of have some globals to say, hey, I'm always going to be using standard, so you can kind of shorten some of these declarations or some of these kind of full namespacing concept, but I wanted to leave this in so you could see what it took to get pi out, because pi is not a native value in Rust. It actually has to come from someplace else, from a library that comes along with it. Kind of like the STIO, the standard library, or the standard library that C++ has. Rust has kind of the same thing. So any questions on kind of that working between C# and Rust and how we kind of create classes and create our objects? No? Okay. Yeah, let's go back. So where? Oh, sure. Let's go. We can go back there. Right there. Yeah, that's a great point. Thank you for bringing that up. So this is how we declare a mutable object. So MUT, if I say let MUT count equals 0, one, it's letting the Rust compiler infer what that variable is going to be of its type, right? So it's probably going to be a I32 or an I64, depending on the operating system. But in this case, we have to make it mutable. Why do we have to make that variable mutable? So I'm going to throw it back to you because you asked the question. Well, right here, it's in a while loop, and we are incrementing count, right? If it was immutable, we couldn't do that. The compiler would tell us, nope, you can't change the value of this variable. So I appreciate you bringing that up. So you wouldn't. So we'll talk about that. That's in this memory. You're setting up the next section. So it's immutable and immutable objects. Both use memory in the same way. It's just that one can modify the value and one can't. So let's look at C# memory management. And I grabbed this, I found this really fun diagram that shows some of the concepts on how the C# or .NET garbage collector works. So if no one knows, there's 3 garbage buckets that things can go in: Gen 0, Gen 1, Gen 2, and depending on, I think, the alignment of the stars and the phase of the moon, objects go through here, and sometimes objects get reclaimed very quickly, and sometimes they don't. And I'm going to be totally honest, I do not understand the garbage collector. I've never tried. I just expect it to do what I need to do, mostly because I work on computers that have 16, 32, 64 gig of memory, which, I mean, don't really care. Now, 30 years ago when I was working on, or 40 years ago when I was working on an Apple II or a TRS-80, yeah, I had to worry about memory back then. But you can see that the garbage collector is very, very complex for most people. Rust, simple. You declare a variable, it lives, and when it gets out of scope, it goes away. Simple as that. If a piece of memory has an owner, think in like pointers. If we all remember pointers, if we learn C or C++, we learn pointers, right? That we have something that points to some memory. In Rust, if a piece of memory, a value, does not have an owner, it gets thrown away. It goes away. And that memory can be reused by something else. And it's as simple as that. So Rust ownership and borrowing is interesting. So you have to really understand this idea of ownership and borrowing and sharing. So a basic ownership, as we see up here, is we have two strings, okay? So we're going to say let S1 equal a string from hello. And this is just saying we're creating a string and we're assigning it a value of hello. And at this point, S1 owns that string in memory. The second line is S2 equals S1. So now we're creating an S2 to point to where S1 went. So because of that, S2 becomes the new owner of that string in memory. S1 is no longer needed. S1 actually goes away. So memory management goes both ways. If a variable name isn't being used anymore, it goes away. Just like if I uncommented that third line right here, this print line, this would cause a compilation error because S1 doesn't exist at this point. There is no S1 anymore. And then you would do a print line to S2 because S2 took over the ownership of this string. So we have to kind of remember this because it's kind of different from C#. Yeah.
After you declare S2, can you declare again S1? Because theoretically S1 just goes away.
Sure, you can redeclare it. Yeah. Because at this point, there is no S1. So you could redeclare it. Yeah, and it won't cause an issue. But you have to give it some kind of value, right? So you would either take over from S2 or put a different, some other new value into that variable. So immutable borrowing is a touch different, and this involves functions. So let's have S1, we're going to create that same string, hello, and then we're going to calculate the length of that. So this is borrowing. So we are letting the function borrow the value of S1, and that's because we put this ampersand. So it's kind of like, we can, when I was learning C and C++, you either pass something as a parameter of a function called either the value or the explicit pointer to it. So in this case, we are sending over a value for that. So at S1 says, you can have the value of it, but you're not going to be the owner of it. And then this calculates the length and sends back the length of S. So S gets a value that's equal to this, and when it gets sent back, this S, because it's no longer in scope, the scope is ended at this point, it goes away. Now, if you have a question on this, what do you think usize means? I like to ask questions, so what's that? Close, but not close. But so usize is a way for you to tell the compiler, hey, you pick the size of, in this case, it's an unsigned integer. But when you say usize, it will either give you back a U32 or a U64. Anyone know how it figures that out? What? The operating system. So if you're using a 32-bit operating system, it will send back a U32. If you're using a 64-bit, it'll send back a U64. So you can try to just work within the constructs of your operating system by just saying I size or U size or F size, stuff like that. But you can see here on this print line, we can use both the S1 and the len because they both are variables that have different values assigned to them. And S1 never went out of scope when it passed a value over to this calculate length. So mutable borrowing is different also. So let's have another string. So we're going to say let mute s. So this is a string that can be changed. And then we're going to say change. And then when we're working with mutable objects in Rust, we have to pass them explicitly, and we have to say at mute and then the variable name. So if we don't do this, the compiler is going to bark at you. And then we get back s, because s comes down here, and it's we are borrowing that string, some string, we're going to change it and then send it back. So that value actually gets changed. That's why there's no return into anywhere. We're actually changing the actual value that's in memory for this, and then we're going to print it out. So that's how we can do for mutable borrowing. And then we can do what we call transfer ownership to functions. It's kind of same or very simple. We create a string. This is another take ownership function. And this doesn't have a return type. You can see down here, it just takes a string. And this will actually take ownership of the memory that S was pointing to. So it comes down here, it prints out something. And if you tried to print out what S is, you wouldn't be able to. The compiler would give you an error. So this is, and this S is immutable. So when we're working with immutable objects and we just send them into a function, that is sending ownership to this function, and then that variable is out of scope at this point and it's gone, or that variable name. So this is, I'm going to quickly go through this because I want to keep up with time, but I have a link so you can get this slide deck. But this just kind of goes through another example of ownership and stuff. So you can look at this later if you want. This is lifetime and function signatures. So this just we have a main and goes, if we have this S2, we get a result where we send in S2 in here as a string, but the problem is this S1 up here, and then we do a let result, which gets a result here. Basically what this is just showing is that for the string 2, at this point the string 2 goes out of scope because string 2 was created within this space. And S1 was created within this space, so that gives each variable name, each variable has a different scope area. So that was just the only thing I wanted to show with that. So let's talk about concurrency. So this is a huge thing with Rust. Rust is really good at making sure that we don't mess up with multi-threading. Anyone do .NET multi-threading? A lot in here? How many people have actually screwed up and gotten lots of bugs? It happens. So asynchronous programming in C#, very simple. I mean, we have our async, we have tasks. I'm not going to go through all this because we pretty much know what this is doing. We have an HTTP client and we're calling something. We're calling a URL and we're getting back the response, and we're ensuring that the success it was successful, and then we're going to send back the response data. Pretty simple. So the main calls this, and it's going to wait around. It's going to wait for this task to be completed to return this string. So Rust has this idea of, for concurrency, also with ownership and borrowing. Ownership and borrowing are very important for concurrency in Rust because Rust wants to know and wants to determine during compilation what is going to own something in terms of, so nothing gets really corrupted or nothing can be messed up when we start sharing stuff between threads and other concurrency types. And it has this idea of exclusive access. So Rust has borrowing rules that will prevent a piece of memory that's being owned by more than one variable. And this is kind of how it limits and how it will stop you from, or it will give you an error if you try to share access with data. So it doesn't matter if it's mutable or immutable. You cannot have two variable names pointing at the same memory space, which is smart, right? Because if I'm going to pass something from a main down to a function that's running asynchronously, which everything runs asynchronously in Rust, it's built into the language. I can't have a variable up in the main pointing to something and something in a function that could be running in another thread also pointing to that. It could cause errors and data corruption. So that is why Rust also will give you errors when you don't borrow correctly, or you may get confused and start getting errors like weird results because you may not fully understand all the different ways that you can borrow. And there's also these two traits that are built into Rust called send and sync. So a send is indicate that ownership of a type can be transferred to another thread, and then the sync indicates when it's safe to return for that type to be inferred by multiple threads. So we can send in a copy of a variable value. So we can say, hey, I'm starting with this number, and I want 4 threads to calculate that number, but you're going to pass through a copy of that variable and not the actual variable memory space. And then there's compile time guarantees. I've kind of said that over and over again, that Rust compiler enforces lots of rules to ensure that data races and other concurrency issues won't happen. Where in C#, you just have to find out if there's an error. That's why we have try and catch. So if something happens in your multi-threaded application, you can catch those errors and then do something with them in C#. In Rust, it will catch 99.999% of all these kind of conditions and not let you compile your program. And then there's also concurrency primitives that are part of the language, and those are threads and channels and locks that Rust can use and the developers can use to even create kind of more safe ways to do multi-threading. So this is a simple piece of code for doing asynchronous programming or multi-threaded. So we say we're going to use thread from the standard library, and we're going to use MPSC, so that's just a different type. And MPSC can have a channel, and that channel can receive information, and it can transmit information. So think of it as a type that has 2 ways to receive and transmit. So we can say that thread, we can create a thread that's going to spawn another thread, and it does some stuff. I'm not going to go all the way through it, but we are transmitting right here. So we are sending some value out along this channel, and that same channel is now going to receive this, and then we're going to show what was received. So this gets spawned out as a thread, and the main function is the original thread that is also receiving something through that channel. So this is kind of a simple way to kind of handle multi-threading and get back results that we want from those threads that we spawn off. So benchmarking. Oh, I have a good time. So speed. So sorry, this diagram is a little small. It might not be easy to read, but I'm going to show you where C# falls on this performance speed kind of list, and where Rust. So Rust is very performant. That's mostly because anyone want to know why Rust is more performant, has better speed than C#? Could be. That's one. But there's a bigger reason. What? It's natively compiled, where .NET is JITted, it's interpreted language. It has to kind of be JITted down, and then that JITted code needs to be compiled down to assembly code for that machine that's on. So that's why it gets speed. It also doesn't have the memory management overhead of the garbage collectors, so that makes it faster. And there's other reasons too, but the two biggest are C# is interpreted, Rust is compiled just like C and C++. And you can see the top two up here are C and C++ that are equal or faster than Rust. So let's take a look at energy. So anyone big up on like green software architecture, kind of looking at your architecture and trying to build software that will use the least amount of energy? I think we all probably have to for the future because energy is going to be kind of a resource that's going to be more and more scarce in the future. So C#, it's respectable. It's right in the middle. I mean, it's better than JavaScript and TypeScript, and Python's all the way down here. Python is a very, very energy inefficient language. Rust, all the way up there. Rust is a very efficient. If we're using C as our baseline, Rust is not very much more energy inefficient than C. It's actually more efficient than C++. So ecosystem and tooling. So let's talk about how you can get into the Rust ecosystem and what the tools are, and because every language has its own tools and its own community and its own things that you have to work with it. So let's talk about those. So overview of a .NET ecosystem. We have Visual Studio and VS Code, and my favorite IDE for doing .NET, which is Rider. We have NuGet. We have ReSharper, which is an add-on, and we have Link. So just some examples of some stuff in the ecosystem. And then we have some frameworks, NE Framework Core, Blazor, SignalR, and Dapper. We probably all use at least one or two of those in our work. So let's talk about Rust and what Rust has for tooling and what you have to kind of learn also when you're developing Rust systems. So we have this thing called crates. So crates has a double use. You use crate to create your program initially, and then you also use crate to bring in those dependencies that you write in your code. If you remember, that thread was a standard library dependency, so crate will bring that code into your program that allows you to work with threads. So the next one is Rust-up. Rust-up is the system that will just keep Rust installed on your machine initially and then updated when new updates to Rust come out. And then we have a thing called Clippy. So Clippy is I knew I was going to forget something in this talk. Clippy is for what? Thank you. Yeah, it's a linter. So this will, in addition to the compiler, by using Clippy, will even help your code be as efficient as possible. So thank you, sir. And then the last one is Rust format. So this is a formatter for Rust. It's configurable. You can use it on your machine or you can use it at a server in the CI/CD to make all your code look the same and kind of formatted the same. We can use Visual Studio Code. So VS Code has some extensions for Rust. I use a JetBrains IDE called Rust Rover. It's actually was created about 6 months ago. It's really good. It's actually free for individual and non-commercial use. So anyone can go out and download it and start using it. It's a really great IDE for Rust. Brings a lot of that JetBrains IDE kind of stuff that we all use every day if you use JetBrains products. We have some frameworks out there. Some of the more popular one. This one's Actix. So this is a web framework. So this allows you to build like web applications. This one's Rocket. I've used this. This one will allow you to, originally this one was built for web APIs, but now it's become a generalized web framework so you can do web APIs and web applications. Warp is another web application or framework, and then we have Poem, which is another one. So kind of these are popular ones for people that want to leverage Rust for more of that web development and web API work. So learning path and practical tips. So this is really where my opinion comes in. The three things that I think everyone, if you want to get into Rust, the three things you start with are the Rust book. So if you go out to the Rust website, they have an online book that basically is the holy grail of the Rust language. And it's called the Rust book. Everyone just says, read the Rust book. Next one is we have Rust by example. So this is a web page that will give you dozens and dozens of examples that you can review and run and see how you do certain things with Rust. And it covers a lot of different areas for Rust. So that's the second thing I would have you look at. And the last one is Rustlings. So these are like katas. If anyone's done programming katas, these are kind of katas for Rust. And the great thing is all three of these are free. They're all created by the community, the Rust community, for people to start using Rust and get familiar with Rust and become skilled in Rust. Now, if you want a book, this is probably the best book that you can buy. There's several books that you can get, but I think this one is really good. I've got a few, but this is the one that I kind of fall back on when I want to learn something or go back and refer to the book to give me some examples and give me the reason why certain things work in certain ways. But there's lots of Reddit groups that you can go to. There's a Discord server, so the Rust team and the Rust community have a really, really great Discord server that you can join and ask questions and get to know people and share ideas and stuff. JetBrains also has what they call JetBrains Academy, and one of the learning resources in the JetBrains Academy is Rust. So you run this, or you create this academy. It creates a project on your, or a package, a crate package on your system that has all these exercises. They're kind of like the Rustlings. They're a bunch of katas that you have to go through to learn Rust. So I highly recommend that JetBrains Academy. And then the last one is they have a great weekly newsletter that gets sent out through email and through RSS called This Week in Rust. And it's a great resource for people to just learn about new things and learn about what people are doing with Rust. So at this point, any questions? Yes? Cargo, yeah, there is cargo. So cargo, well, cargo is also used for package. You're right. So I didn't include cargo in here. So yep. So cargo is used to import the crates that we create. So, and the thing about crates is you can create your own crates and put them out for the community to use. Kind of like Docker, if anyone has created a Docker image and then put it up into their cloud so people can use it. You can create new things, new crates, and put them up there. So appreciate it. See, I told you I would miss one or two things. So it's good that people call me out. So I appreciate that. Any other questions? We have about 5 minutes left. Yep, in the top. Say that one more time. Spank. Oh, span. You know what? I'm going to be honest. I don't know if it does or not. I haven't really looked at that. So I couldn't tell you. Sorry. Okay. So we have a few minutes left. If you want my contact information, it's all here. I do have two things I always like to plug. I'm writing a book. So right now I'm writing an online book for free. It covers C# for networking, programming. It's going to have 17 chapters. I think I'm up to 8. So I'm hoping to have all 17 chapters done by the end of the year. You can just go to c#-networking.com and see that book and read up. It starts from just very basic stuff and works up for a very knowledgeable C# networking knowledge. The other thing is I do a podcast with a few friends. It comes out every 2 weeks, and it's called The Breakpoint Show. So if you want that, just go to breakpoint.show. And with that, I will give you the QR code that you can go get the slide deck for this. And the repository that this links to will also have future Rust demos that that I have planned to build, and I will build, and I'll put those out there. So with that, thank you. I appreciate you giving me your time. And I will be around tonight. I'll be around tonight if you want to talk Rust or if you want to talk anything .NET. I'll be around for the party and the concert and stuff. But I am leaving. I'm going home tomorrow, so I'm going to be flying home in the morning. So I love Copenhagen. It's a great city. Denmark's a great country, so everyone's been very welcoming. So I appreciate you especially for showing up to my talk. So thank you.